Hello and welcome everybody to the October OpenNTF webinar. This is going to be using Passkeys for Domino web authentication with Paul. As usual, before that, we'll have some preliminaries to get through. Our agenda for today is going to be the standard. We'll have these welcome bits, we'll have our presentation, and then at the end we will do the Q&A. And naturally, before everything else, we want to thank our sponsors that keep OpenNTF running. So HCL made a contribution that helps our organization. That's primarily, it funds these webinars. These things are not free, and this makes it happen. It helps with various other running the organizations. It helps us help community events, all that. It's been what keeps us chugging along. But really, what keeps us technically chugging along is that Prominent handles our IT-related services. They do the hosting for us. They do infrastructure management. We got to have servers, and they run them, and so that makes it so that we can, not have to pay a big AWS bill. So very much thank you to both of them. And I want to talk a bit about our community. So we recently had elections, and first I want to thank Paul Withers for all of his service. He stepped down at the end of this election cycle. He was on the board for a very, very long time. He's been in the community and still is forever. And so we definitely want to thank him. And then we also want to welcome David. He's joined the board. He's been a fixture in the community for a long time, and now he is, hopefully going to be a fixture on the OpenNTF board. He joined us for our first official session with our meeting the other day, and it's always great and very interesting when we have a new person joining the board. But that said, you don't have to be on the board to participate with OpenNTF. We are all OpenNTF. We are all volunteering to do this. The community is not the board. The community is not just the people who post projects. The community is whoever participates. So we are all here to learn from each other. We're all volunteering. You don't have to have a huge idea. You don't have to have a huge contribution. Just answering questions in Discord or a little outside the OpenNTF community, but on Stack Overflow or elsewhere. That's great. So no idea is too small. No effort is too small. So we have snippets for that reason. If you just have a small bit of code, you just have a small idea, and even a project. It doesn't have to be a giant, massive sprawling framework or all-encompassing application. Just a small thing saying, hey, I made a demo that does this. You can run it on your server, give it a shot. That works great. So anything, documentation is the long unheralded hero of contributions. The more documentation that can come, especially, I always like to say that the worst person to write documentation is developer, both because developers don't want to do it and because developers don't know what needs documenting, because the person writing it already knows everything. That's how it's supposed to work. They don't know what you're going to run into if you don't know already. So having somebody who's not the primary developer assist with documentation is invaluable. It's one of the absolute best things you can do. So I always want to drive that one home. And we have a couple upcoming events in the community. So the Let's Connect Nordic user group is coming up very shortly. So I imagine if you're not already planning to go, this may be a little tight turnaround, but you should take a look it up. And if you can make it, do so. If you are going, enjoy. I expect it to be good. And then on the OpenNTF side, next month we have a webinar on LLM integration. So we will have more details on that when the emails go out at the start of the month, but that should be interesting. And then for December, we have our now traditional OpenNTF end of year celebration. So this is, in lieu of a lot of us being able to hang out in person, we have these open calls that actually they work pretty well. They can, they're not the same as hanging out in a lobby bar, but it helps. So we very much encourage everybody to join us there. And also, we encourage you to join us on Discord. This very imposing square is the QR code that will get you there. On the next slide, we do have the URL that will get you there if you just want to type that in. Our Discord community is pleasantly active. We remain very pleased with how things work there, how many people are there. It's a great place to ask smaller questions or just chat or answer other people's questions. It's good and active, and it's a good low-key place. Much lower barrier to entry than packaging up a whole project or something like that. And speaking of questions, we are taking questions during this webinar. We will answer them at the end. So there is a question pane in GoToMeeting. And we always like to answer the first question right away. Is this recorded? Yes, it's being recorded right now. It will be on YouTube. There is a bit of a manual process to this. There's some editing that we go through, so it won't be on YouTube immediately after the presentation, but it will be there eventually, and on our webinars page on OpenNTF. So use this question pane, and then at the end, presumably I will go through all of these questions and ask them. So we'll do all that at the end, and by all means, ask away. And then if you have an unrelated question, post it at openntf.org/discord. So that will get you to our Discord. That's just a great place to be again. So we welcome you all there. And now I'm going to hand the reins over to Paul for using Passkeys for Domino web authentication.
Hello, and welcome to using Passkeys for Domino web authentication. Passkeys are being heralded as the future for web authentication, supported by Domino and modern web browsers. But what are they, and why should you consider using them? My name is Paul Harrison. I'm a software developer at FoCul Ltd, based here in the UK. I'm focused on developing a new Angular application to replace an existing front-end Pages application using custom REST APIs to maintain access to its existing data and business logic. So not moving away from Domino, but simply changing the front end to Angular. I have over 20 years experience with HCL Domino and notes covering everything from support and administration to infrastructure, migrations, and of course development. I'm a proud 4-time HCL Ambassador. I'm very pleased to say this is my second time presenting an OpenNTF webinar. So in this session, we will explain what passkeys are and how they work using existing web standards to provide a highly secure yet easy to use web authentication experience for users. If you use Gmail, GitHub, Twitter X, Facebook, or eBay, then you may already have been encouraged to switch to passkeys for authentication. Although the underlying client-side web application APIs have been available for a number of years, client support for passkeys from Apple and Google only became available last year. And so this is now the real driving force behind passkeys. Although, of course, this is only half the story, as websites also need changes made to support passkeys, which is where this newly added feature of Domino 14 fits in. Perhaps confusingly, passkeys is really a consumer name for the underlying technologies that are used, such as the web authentication API, which is also known as WebAuthn. But it does add to it device support and synchronization capabilities. And for the purposes of the webinar, it's convenient to consider the terms WebAuthn and passwords interchangeable. So this is our agenda for today. We're going to look at what's not so good with passwords and what makes passkeys better. We're going to look at a passkey client demo. You may have seen earlier ones from HCL. I've added to that a little bit. We're going to actually look at a Domino passkey setup. We're going to talk about how passkeys work for those that are interested. We're going to talk about passkey ecosystems, which are the things that really make passkeys viable. Virtual authenticators, which we can use for testing and troubleshooting, and then we'll summarize everything up. So passwords versus passkeys. So let's start by reminding ourselves about what is wrong with passwords. Most importantly, I feel passwords are disliked by users, and they would really rather not have to use them. This results in bad practices such as simple guessable passwords. So for example, password or password with the O replaced by 0, or 1, 2, 3, 4, 5, 6, etc. And also to passwords that are often shared between multiple systems and services. So if one password becomes exposed, that could be used against other systems. Passwords are subject to phishing and man-in-the-middle attacks. Passwords are also saved on web servers, which can lead to a potential risk of data breach, and also making them susceptible to directory and brute force attacks. Complex or rule-based passwords, so these are password rules where you need one capital letter, one lower letter, 4 numbers, and the age of your dog, almost, in my opinion, discourage passwords being changed on a regular basis because they're often difficult to create, remember, and use. However, password managers can help in this situation. Multi-factor authentication, or MFA, is a significant improvement, but essentially it's just an extra layer on top of the existing password mechanism, so still vulnerable to phishing and man-in-the-middle attacks, plus also mailbox and SIM swapping attacks, which seem to become quite popular at the moment. The impact of an exposed password may not always be immediately obvious. If you imagine a hacked email account where the bad actor can reuse the exposed password multiple times, waiting for a particular event or events to occur. So the impact isn't always immediately obvious. So why are passkeys better? Firstly, they're standards based. The standard is called FIDO2 and comprises of 2 specifications. The Web Authentication API, which is usually referred to as WebAuthn, which handles the actual authentication process between the client and the web server, and the Client to Authenticator protocol, more simply referred to as CTAP, which allows the client to access authenticator devices such as the user's phone. Together, they provide for a strong authentication experience. Secondly, they use public key cryptography to create a unique asymmetric key pair for each account and website on a device. The private key, which is securely stored on the user's device in their credentials manager or password manager, in actual fact the authenticator, is used to sign web-generated challenges when attempting to log in or register, whereas the public key, which is shared with and stored on the website during registration, is used by the web server to verify a client-side signed challenge, and we'll talk a little bit more about that later. Passkeys provide improved usability and a more streamlined authentication experience than multi-factor authentication. They use the same simple actions that users are familiar with and use multiple times each day, which is logging into their own devices using biometrics or PINs, so face or touch ID and PINs. Password authenticators can either be standalone physical devices, so this will be FIDO keys such as Google Titan or Yubico keys, and there's some images of those in the screenshot below. And these can be USB based or NFC or even Bluetooth, or we can use a user's device such as their phone or laptop which also allow for passkey synchronization between these devices. Keys can't synchronize passwords, or passkeys I should say, whereas devices can. Passwords may still be required for initial passkey registration and if need be for passkey recovery, if for example you lose a device. Sorry, did I miss a slide there? It's also important to note that passkeys only validate your identity by presence. The underlying authentication and authorization mechanisms within the website remain unchanged. So if your website's using cookies or JWT tokens, that all remains in place. All you're doing is replacing the username password aspect of the authentication process. So passkeys have a number of security benefits. Passkeys are user and website specific. So that means every website you go to with your specific user credentials generates a unique set of keys, and also on that particular authenticator device or ecosystem. And it does that by design. So that prevents phishing via fake websites. The challenges that are exchanged during the login and registration processes are random, one-time, and time restricted, thus preventing man-in-the-middle attacks. And no passwords are stored on the website, and this reduces the impact of data breaches. I should very quickly add that the latter is not strictly true for Domino. In fact, it's not true for Domino at all. And perhaps also many other systems, as you will need it to initially log on and create a passkey. and then perhaps also for password recovery if you lose your devices. But technically, from a password perspective, passkey perspective, sorry, in the specification, all that is required is a unique identifier, such as, for example, an email address. And hopefully, if we have enough time, we'll see an example of this in a non-Domino based demo later. As far as browser availability is concerned, I mentioned that WebAuthn has been around for a number of years. The passkey aspect of that has also only just been around for about a year, but the coverage is exceedingly good now across most browsers. And this effectively includes the passkey aspect of it, so the synchronization, which we'll talk about later. So coverage is very good. I think Firefox has a little blip, which I understand relates to Touch ID not being supported on Apple devices, but don't quote me on that. Okay, so I've got a little demo here. I was hoping to do the demo live, but unfortunately the demo gods were against me this time. So I've got a little video to go through, and hopefully it will be fine. So what we're going to do, so on the left hand side I've got my Mac in Safari. On the right hand side I've got my iPad, and what we're going to do, we're going to register and log in using two different accounts. Each time we're just going to use, well, for the first two times, there's actually 3 logins. We're going to log in using Safari on the Mac, so the left-hand screen, but using 2 different authenticator methods. So for the first account, we'll use the credentials manager of the Mac itself. And then for the second account, we'll use scanned QR codes and use the credentials manager on the iPad. The devices are synchronizing the credentials, so we may see the credentials, each device's credentials appear on the other device, but that's fine. So let's start the video, and I'll talk through that. So first we're going to log in. We're going to use Beer Drinker as the account name, and we're using autofill to complete the password, so not to be confused with passkeys. So this is just autofill. And because we want to create a passkey, we select create a passkey and we click login. We then follow the prompts, which essentially just asks you to create a passkey. So now the Mac is asking, or the credential manager on the Mac is asking, do we want to create and save a passkey for Beer Drinker? So we'll approve that on the Mac by fingerprint. And what that's done, that's logged us in and created a passkey for Beer Drinker in the background. So now what we'll do, we'll log out. And again, this time we'll actually use login with a passkey. So note that we're not entering a username or password. All we're doing is selecting login with a passkey. So, got it. So what the Mac is now telling us is that it's going to sign us in using a passkey for Beer Drinker, and I need to verify that by touching the Touch ID. So we'll do that. And that has logged us in as Beer Drinker without having to reuse or resubmit, I should say, our username and password. So for the second demo, it's very similar, but what we're going to do this time is use the the iPad as the authenticator. So in this case, the Mac itself was the authenticator, so it was the browser and the authenticator. So the process is very similar. This time we'll log in as Wine Drinker. So again, we pull the username and password using autofill, just to save a little bit of time in typing. And what's different this time, we follow the prompts. So we want to create a passkey, we want to log in. So we click create a passkey. Now this time, We're not going to create a passkey for wine drinker on this particular device. What we're going to do is we're going to select other options. This comes up with a choice. So iCloud keychain is basically this Mac and any other Apple devices. We can also pick iPhone, iPad, or Android device. So basically any device with a camera and that supports passkey, or an external security key. So that would be a FIDO key. So we're going to select the middle option. So a passkey with a device with a camera. We click continue. Eventually. Right. So now what happens is the Safari has displayed a QR code, which is basically inviting us to scan that with a device. So I'm going to use the iPad once I wake it up again to scan that code, and we'll stop it once that process has happened. So we just use a QR code scanner, scan the code. Now what's happening at this point is the iPad is connecting to the Mac. It needs Bluetooth to do this, and Bluetooth on both devices, but the devices are not paired. It creates a ad hoc Bluetooth connection between the two devices, which is really quite good from perhaps a corporate perspective, where you're using a corporate PC, but maybe your own personal Android device to do the authentication with. So there's no Bluetooth connection other than a ad hoc connection, and all the information for that connection is in that QR code. So what's now happening is the Mac is telling us to use the other device to save the passkey. On the other device, what we need to do is use Touch ID on that device to create that passkey, which we'll do. And then, as if by magic, the Mac logs us in. So what's happened there is the Mac has asked the authenticator to create a passkey. The authenticator has created that passkey and passed it back to the Mac. The Mac then passes it back to the server, and we'll look at those steps a little bit later. And then, just to show that we can actually now still log in using this wine drinker account using the QR code, we'll follow the same steps as we did for beer drinker. So we're using wine drinker, but we'll click on, let me grab that. So what's happened now is, whilst I've been recording the video, the two devices have synchronized. So we're actually seeing on the Mac the beer drinker account I created, the passkey I created on the Mac, and the wine drinker account passkey I created on the iPad. So in line with using QR codes, what we're going to do is select other sign-in options, because we don't want to use those particular ones on this occasion. What we want to do is a QR code again. So again, we pick device with a camera. We get another QR code, which this time we scan in exactly the same way. And this time, instead of creating, so it has the similar communications, but instead of okay, so let me explain that for a second. So again, what's happened is the two accounts have synchronized. So the iPad is offering us, well, which one do you want to use? As we want to log on as wine drinker, we're going to select wine drinker and verify that on the iPad with Touch ID. Which logs us in successfully as wine drinker on the Mac. So I've got one third part of this demo, which is just a variation on this. So what we're going to do here is we're actually going to use the iPad log in. So we'll open a browser to the same page. We're not going to enter any credentials. What we will do instead is log in with a passkey. So again, it asks us which passkey we wish to use. And on this particular occasion, we're actually going to use the passkey that we created on the other device, the first device on the Mac. So we verify, there we go. We verify that on the iPad. And then that logs us in on the iPad as the original beer drinker account. So I'm hoping that all made sense. As I say, it's important to realize that the Bluetooth is required on both devices, but they don't need to be paired. And obviously they need to be in fairly close vicinity. So let's move on to the next slide. So a Domino passkey setup. So enabling passkeys for Domino 14 is very easy and takes under 5 minutes and comprises of only 3 or 4 simple steps. I do have slides for this, which we'll review shortly afterwards. But what I thought we'd do is actually try and do this live. So if you bear with me 1 second while I just reorganize things. Okay, so this is the Domino server that we're going to be connecting to. As you can see, it's got this lovely server login, and we'll just refresh that just to make sure that's all working. Right. So what we're going to do is to implement the steps that we need to enable this. So we will go into Domino Administrator. There's essentially three steps. So the first step is to create a Passkeys database or passkey database. So standard Domino, so application new. We'll pick our server. We can call it anything we want, but its name must be passkey.nsf. It must live in the root. So lowercase passkey.nsf. We'll select the Domino server as our source. It is an advanced template, so we'll select that, and then basically we look for the passkey database. If you bear with me 1 second. Yeah, in there somewhere. Where is it? I've lost my file. Where's it gone? There we go, passkey. So passkey.ntf. We create that file, that database, I should say. This unfortunately is dependent upon the speed of the server, but we're there. That didn't take too long. So this is the Domino passkey database. So basically this database keeps track of all the passkeys on your system, and effectively it acts almost as a proxy between the WebAuthn connection and names.nsf in terms of authentication. I don't know the full ins and outs of everything, but it's quite a simple interface. The second part that we need, so we've created our passkey store, so that's good. The second part of the equation is a very simple change to the internet site. So I'm assuming that you're using an internet site document here. So there's one thing we need to check, which is that we're either using a single server or a multi-server SSO session authentication. It only works with those, to my knowledge. We go onto the security tab, we check the passkey WebAuthn option, and we save that. So we've created the database or the store. We've told Domino to use that, which is quite good. The third part of the equation, and we do need to do a reboot at some stage. The third part of the equation, if you're not already using one, is to create a DOM CFG database. So we'll do that now as well. So we started off with quite a vanilla Domino web server. So again, create it on the server. We need to call it dom.cfg.nsf. Dom config. It also is an advanced template. There we go, domcfg5.ntf. So we'll create this database as well. Obviously, for the purposes of the demo, I'm not going through hardening ACLs. So you should go through and harden them to your standards. The default ACLs are actually, I think, probably secure enough, but each site and customer is different, so it's important to get that configured to your own standards. So let's go back to our browser, and we'll just refresh this, and we'll see what happens. Hopefully, oh, we got a nice. Oh, shit, didn't mean to see that. Hopefully, we've got a nice, shiny, new, modern HCL login because of the DOM-CFG. So we've got 2 steps left. First step is to add a mapping. And what we need to do is tell the login process to use a specific template within DOM-CFG. And this is the template or form that we need to use. Login user form passkey. So we save that, and all we need to do now is a server restart. So we'll tell HTTP restart. This should only take a couple of seconds. There we go, we're done. And now, if I refresh this now, we have the passkey options and log on with a passkey. So just to prove that this all works, this is our password store. There's no documents in there at the moment. What we'll do, we'll actually register a new user for a passkey. So the user is called Cider Drinker. You've probably detected that there's a theme here. Again, as per the video demo, we create a passkey and we log in. So this is perfectly live. Create a passkey. Now this is a Windows 10 device, which has caused me some angst in the past, and I'll mention that briefly later. If I remember my PIN number, so that's equivalent to the Touch ID on the iPad on the Mac. That's logged us in as Cider Drinker, exactly as you'd expect. And if we actually look in here in the Passkeys store, refresh that, we'll see Cider Drinker there. So it gives us some information about the authenticator, a credential ID, the name of the user. It does show last login, but only once you've logged in. So if we log out, and this time we'll log in purely with a passkey. I'm hoping this works. Yeah, so we'll pick Cider Drinker. You can see the user interface is quite different from the Mac, and that's probably the most significant difference with passkeys. Every authenticator will have its own user interface. They're all doing the same thing, but so we'll log in there. So that's successfully logged in as Cider Drinker using a passkey. And if we just refresh this now, we'll see it's picked up our login time. You can also open one of these documents up, and there's a degree of information in there. There's probably not much useful information in there unless you really know what you're doing, but there's enough to be able to debug the system. So that's effectively passkey enabling a Domino server in under 5 minutes. Okay. As I mentioned, I do have slides for these. So I've got the 4 steps: creating the passkey database, the passkey setup in the internet site document, making sure we're on a single server, and we select passkey. I've actually added creating the DOM-CFG in there. HCL actually say it's optional, but I actually think it's highly recommended because it gives you a much nicer login dialog. Obviously, you can customize that or create a variant of that. And here we mentioned the form keys, and I also selected this for the entire site. And there's just some screenshots of the before and after, so you can see the differences that enabling passkeys and DOM-CFG have had. So now that we've seen passkeys in action, let's dive a little deeper into how they work. We'll first look at a registration flow and then a login flow. So if you recall, registration flow creates the passkeys and the login flow uses the passkeys. These are the diagrams that I'm going to show are quite slightly simplified just to make it a little easier to talk through. And if you're familiar with OIDC or SAML flows, then these should look quite familiar. Okay, so we're going to start with the user registration, or in passkey terminology, the attestation flow. So what we'll do, we'll start with so let me just explain the parts of it. So we've got the client in the middle. We've got the relying party, which basically is the web server you're connecting to. So relying party is, again, passkey terminology. And we've got the authenticator over here. And the two bits of the specifications that work together to make everything work is WebAuthn, which effectively deals with the client and the web server function connectivity, and CTAP, which connects the client to the authenticator. So starting with the client or a user's device, it may be a browser, it may be a phone. The user visits a site that supports WebAuthn and requests a registration challenge. The website then generates a random challenge and sends that together with some configuration information about itself back to the client. So back to the client here. This challenge is then passed to the authenticator, from the client to the authenticator, and that authenticator could be your mobile phone, a hardware FIDO key, or some other device capable of generating and storing your cryptographic keys. The authenticator verifies that the user is present using biometric or PIN. So in the case of Apple, it's Touch ID, or the demo I gave earlier was Touch ID. And if the user is present, by verifying that, then a new asymmetrical cryptographic key pair is generated. As I mentioned earlier, it's unique to that authenticator, that website, and that user account that's trying to be used. The authenticator then stores the private key in its credential store, signs the challenge with it, and then returns the signed challenge together with the public key back to the client. The client then passes the signed challenge and the public key to the website. The website validates that the returned signed challenge, the website validates the returned signed challenge against the user's passed public key, so what is just passed. And if it matches the challenge that it sent out earlier, it stores the user details in the public key and the user is logged in. And that's the part that's the storage bit, is what the passkey store is doing in Domino. At no time has any biometric or other information other than the public key and the signed challenge left the authenticator and thus the client. So now we've registered, we can proceed to log in, or assertion, in passkey terminology, which is, and you'll see that the flow is very similar to the registration flow. So again, we start with the client. The client visits the website that supports WebAuthn and requests a login challenge. Challenge comes back, generates a challenge. This, if you recall, it's a random challenge, one time, and is time limited. The challenge is then passed by the client to the authenticator, where after verifying that the user is present using biometrics and PIN, the challenge is signed by the securely stored private key for that particular website user. And then the authenticator returns the signed challenge back to the client. The client then passes the signed challenge back to the website. The website validates the return signed challenge against the user's registered public key, which, if you recall, was passed as part of its registration process. And if it matches if that challenge matches the one it sent earlier, the user's logged in. Again, at no time has any important biometric or other information left the public key. So everything's pretty much random and relies on the cryptographic keys for signing and verification. So ecosystems are the key to wide-scale adoption of passkeys, as they provide secure synchronization across a user's device and also redundancy if in the event of losing a device. Broadly, they consist of two types: those from first parties such as Apple, Google, and Microsoft, and those from third parties. And both types we'll talk about a little bit later. The ecosystems allow for the synchronization of a user's passkeys between their trusted devices, and also adds redundancy in the case of a device loss. If you're using a key that's not a FIDO key, that's not really part of the ecosystem because they're standalone and they don't synchronize anything. So we've got some examples here, the main examples, frankly. We've got Apple, which uses the password app, the new password app, and iCloud keychain across all Apple devices that share a common ID. We've got Google Password Manager, which supports Android devices, Chrome devices, plus also non-Google OS devices. We've got Microsoft, which really only supports Windows devices, and third-party authenticators or ecosystems. So let's look at those in a little bit more detail. So in the Apple ecosystem, quite simply, passkeys are synced via the iCloud keychain to all compatible Apple devices that share a common ID. So this is in the Apple settings. There's an option to synchronize keychain information. And that works against all Apple devices, iPhones, iPads, Macs, and pretty much anything else. As of iOS 18, so the version that was released very recently, passkeys are actually managed via a new dedicated passwords app rather than the keychain itself, but they still actually are stored in the keychain. It's just a friendly interface to passwords. Google's a little bit more complicated, and as a result can synchronize between Android devices as well as Chrome as well as Chrome browsers running on other operating systems. Synchronization is via Chrome and the Google Password Manager. And if we look at the table, we can see that pretty much the Google Password Manager supports all the devices. Chrome OS is in beta. iOS and iPad OS isn't quite available yet, so that still falls back to using the iCloud keychain. But that's changing. That has planned support. This is the table from, I think, about this time last month, when there was a big change to Google and they effectively introduced the Google Password Manager and the ability to go across devices. Prior to that, devices like Macs would use the iCloud setting. So that's all positive news. As I say, this all changed significantly for the better just last month. The Microsoft ecosystem currently seems very limited in comparison with those of Apple and Google, particularly Windows 10, where it supports extremely limited to the point where you cannot even delete old passkeys in it without relying on third-party solutions, as I discovered earlier this week. Unsurprisingly, Windows 11 has much better support, but it's still evolving. Just last week, Microsoft announced some improvements, specifically a synced password provider and a plugin model for third-party passkey providers. Not entirely sure what they mean yet, but we'll see. And that was last week. So third-party ecosystem. So this is where it gets quite interesting. So the main advantage of third-party password managers or credential managers is cross-device, making them ecosystem independently. So you can run one on your Android device, you can run one on your Mac. This might also be helpful for those devices that maybe don't formally support passkeys, or perhaps are Android based, but the OS doesn't support passkeys yet. One that springs to mind is probably OnePlus devices. I say most importantly, they're device and ecosystem agnostic. So you install the system and you can install it on pretty much any device, and they will all synchronize. So popular examples include, and these all have free lifetime or limited time trial versions available, 1Password, Proton Pass, and Bitwarden. They all synchronize via their own individual cloud systems. Bitwarden is interesting that you can actually self-host that yourself. I'm not sure if that's a good idea. I'm not sure if cloud hosting is a good idea, but nonetheless, that option exists. They all have native apps for the common devices and browser extensions for the common browsers. And increasingly, they have business or enterprise versions available, which gives businesses more control over that. One thing to note, they can be a little bit problematic to set up on devices due to differing device security constraints, as some devices only allow a limited number of password managers to be enabled. For example, the latest iOS allows up to 3 password managers to be enabled, whereas Android supports multiple, but only one preference can be enabled at one time. So hopefully in the future that situation will improve a little bit. So now you hopefully have a basic understanding of how passkeys work and they can be used. Some of you, particularly those who may have an interest in end-to-end testing and CI/CD pipelines, are probably thinking, well, if I need to be present to validate a login or a registration, how's this all going to work? So the answer to that question is virtual authenticators. So the WebAuthn specification makes provision for virtual authenticators, which can be enabled in browser DevTools. Currently, it's only supported in Chrome and Edge. I think when I was looking into this last month, there might be an extension for Firefox, but I couldn't find anything in Safari at all. These virtual authenticators can also be accessed via the Chrome debug protocol, and it's that ability that allows end-to-end testing tools such as Cypress to directly access them. So if you didn't know, the DevTools in your browser has an API that applications can connect to. So that allows them to access these virtual authenticators and continue testing even when a passkey authentication flow is required. So it's kind of bypasses the physical aspect, but it is a virtualized authenticator. Furthermore, these virtual authenticators can be used to gain an insight into how passkeys work at quite a low level, and also aid troubleshooting and testing. So let's take a look at this in our final demo. Again, I've got some slides that cover this, but we're trying to do a live demo because it's more fun that way. Oh, sorry. Go back. So what we're going to do, we'll do a live demo first using Domino. So if I get my browser back. Where is it? There we go. Okay, and I do show in the slides how to go into how to enable this once you're in DevTools. So here we've got a nice logon screen. We're going to DevTools in this. So this is using Microsoft Edge. We're going to DevTools. And the WebAuthn stuff is quite well hidden. Normally when you go into it, you'll probably see console, you may see network, but what you need to do is click on the, again, this is Edge, Chrome, it's slightly different, but it is there. Clicked on the plus, and hidden right at the bottom here is WebAuthn. So we'll select that. Not the most exciting of dev tools, but what we need to do is enable virtual authenticator environment. We click on this, and it allows us to actually create a virtual authenticator. We can do things like selecting various protocols, transports, so USB, Bluetooth, NFC. Now I had a lot of difficulty trying to get the right combination of things to work, and there may be other combinations, but this is the combination that seems to work quite happily with Domino. We need to select support resident keys and user verification. Once we've set up our new administrator, we add the administrator. So here's our authenticator. I do apologize. So here's our authenticator. It's active, which we can see from there, and this is where any credentials we add to it will be displayed. You can completely ignore this bit down here. That's should you want to create an additional authenticator, but you don't need to use that for the purposes of this. So what we're going to do is we're going to create, what I'll go back over here to Domino. So you can see at the moment we only have cider drinker. So I prefer beer. So what we're going to do is log on as beer drinker, create a passkey, and the authenticator we're going to be using is this virtual one. By doing this, this is automatically enabled, and this bypasses any authenticators you've got on your device. So we click login, and you should be familiar with this process by now. We'll create a passkey. Yes, we want to allow that. And you can see there now that we've should have made that a bit wider. We've logged in as beer drinker, or we've registered, I should say we've registered and logged in as beer drinker. And this is actually the credentials that it's created. So all of a sudden you can start looking at what kind of information is stored within an authenticator store. And if we go over to the Passkeys store here, we'll see beer drinker has now been added. If we open, actually we don't need to do it from there, we can do it from here. You'll see that the ID back here in the authenticator, this ID field here, SNI 50 whatever, actually matches the credential ID here. So you can actually see which authenticator matched it. Unfortunately, it doesn't give you a name. It does seem to give you this random number, which I did try reverse engineering to see if it matched anything within the virtual authenticator. I suspect it should be this field here, but I couldn't work that out. So if there's anyone from HCL watching this and they know how to do that, please get in touch. I'd love to know. So what we'll do now, notice there's no login date there. So what we're going to do, move that out of the way, we'll log out. Let's make this a bit smaller so we can see what's going on. We'll log out. And this time, just to prove that it all works, we'll log in with a passkey. We're going to use beer drinker again, continue that. And as before, exactly as before, that's logged us in. And if we refresh this now, we should see a login date there. So that, as I say, that's quite useful to test web servers, such as Domino here, and also to actually try and match up information. So it could be that a user has, actually I probably should go back to that one. It's possible for each authenticator would create a new entry in here. So if you knew which authenticator you were using, you could ask, and you needed to revoke that passkey, then you'd have to, at the moment, you'd need to ask your administrator to revoke that passkey, and then you go through the registration process again. So we talked about, that's a Domino one. If you bear with me 1 second, let me just, that's the virtual authenticator setup, which we've run through. And so you can ignore this lower section unless you wish to add another one. And you can delete using the delete key. And if you did create another one, you can only have one active at any one time. And again, we've gone through the registration process. So we log in, create a passkey. It creates this ID here, which relates to the ID in the passkey database. That's the record for that. There's also another interesting third-party site that I've used quite a bit for testing. We'll go back to the demo. We'll just leave this slide up for a second. And we'll go back to the demo. Passkey discussion database. There we are. So what we're going to do, we'll log out here, and we're going to keep our authenticator here because I know that works. And what we're going to do is go to a website called webauthn.io. And this is an immensely useful site if you're doing web authentication, and I recommend people go and have a read of it. There's lots of good links on there, but it's all about WebAuthn and passkeys and stuff like that. So very simple user interface. So we can put a username here. Remember earlier I mentioned that you don't have to have an account. Technically, you don't need an account on the system for passkeys. You can actually create, as long as it's a unique feature. So we'll create OpenNTF. Exactly as, well, not exactly as before, but we have the option to register. So we're not logging in, then creating a passkey. We're actually going to register a passkey directly from here. And there's also a number of advanced settings that you can use to fine tune this, and this is interesting to be able to match these settings to. I'll leave you to explore that if you wish to. So what we're going to do, we're going to register OpenNTF as an account, shall we say, on this site. Excellent. So it's not the most exciting of websites, but you can see what's going on. So success. So it's registered us, and you can see over here. Oh, I should have mentioned, this is remember I mentioned the relying party? So effectively the web server you're connecting to. So this is the relying party ID. So that, again, part of the uniqueness. So this is our one for WebAuthn.io. So we've created a passkey. So now we can try and authenticate. We can get rid of that because these things aren't necessary. We click on authenticate. We select that we want to use the passkey for the unique identifier OpenNTF on WebAuthn.io and click continue. And success, we're logged in. So it's really quite simple for testing things without relying on a back end to test things against, particularly if you're doing development where the administrator may not give you access. I don't believe, from the work I did before, there doesn't seem to be a web interface into the passkeys database that I could figure. Again, if there's anyone from HCL listening, then please get in touch. So what's interesting here is it's shown us the credentials for OpenNTF. So this is equivalent to the passkey store in Domino. And here again you can see the ID, so KGX. And you can delete that. So if we delete that on the server, this again is what makes this quite interesting. If we delete this on the server, so we've still got our passkey locally, but we delete it on the server. Well, now, we're still logged in. If we click on try it again, that will effectively log us out. So this time we've still got our passkey. We'll go to authenticate. So we've got a message saying that we have a passkey for OpenNTF. Do you want to use it? Yeah. But the server no longer has that passkey record because we deleted it. So we get an authentication failure. So that's really quite good for doing things. But we can go and register We can go and register again if we want. That's not a big problem. And if we authenticate this time, whoops, authenticate this time. Let's try that again, sorry. Bob looks quite common. So we'll authenticate this time. And you can see that a lot of other people have used Bob as a unique identifier. So in the real world, your unique identifier would be truly unique on your server, but Bob seems to be quite common today. So that's the virtual authenticators for WebAuthn. I included that one because I thought it was really quite useful to be able to test passkeys outside of Domino and gain a better insight of passkeys and WebAuthn specification and capabilities. There are a couple of other websites around that you can do similar things. This is my favorite one. So, and as I said earlier, and as I alluded to earlier, no password is technically required, but it is a good example of how passkeys can work in that kind of mode, which isn't really a Domino mode. Okay, so we've just about finished. But before we do, I'd like to just quickly recap what we've covered so far today. Excuse me. So despite multiple attempts over the years to improve the security of passwords, particularly multi-factor authentication, they're still fundamentally flawed, in my opinion, and at constant risk of attack from multiple vectors. Passkeys address many, if not all, of the issues with passwords. So phishing, man-in-the-middle attack, and data breaches, the important ones. And these bigger issues that are solved help to resolve some of the smaller issues like password reuse, uniqueness, and users being lazy with passwords. And they currently provide state-of-the-art protection for end-user web authentication. The end-user passkey experience is consistent and already familiar to everyone that uses a mobile device on a daily basis or even monthly basis. People are familiar with Touch ID, pins, Face ID, etc. With Domino, passkeys are very easy to set up and quick to enable. And also, you don't actually need an ID vault, which I think is quite a bonus these days. The browser dev tools provide virtual authenticators for system testing and for troubleshooting. Which can be good, certainly particularly in the early days of setting this kind of stuff. And if you've got a device that isn't working, then things like WebAuthn.io may be really good for trying to test that. Whilst passkey ecosystems continue to improve and evolve, there's still more to be done. For example, better device support for multiple concurrent password managers and standardized credential portability. And that's importing and export credentials. In fact, only a couple of days ago, the FIDO Alliance announced an initiative to look at this very topic. So that would allow passkeys to be passed between password managers, hopefully first party and third party, so you're no longer constrained by too much. So the future looks very promising. End-user passkey take-up will continue to improve significantly as website adoption increases to reach critical mass. As I say, it's built into all the clients now. The dependency now is on the websites adding that support. And it is only, as I mentioned right at the start, passkeys do only replace the username password aspect of the authentication process. So everything else remains the same. So it's actually quite straightforward. And because it's standards based, there's lots of examples of that. And if you go to WebAuthn.io, you can follow some of the links there. So to conclude, passkeys currently provide state-of-the-art protection for web authentication. They do, however, have a dependency on credential or password managers. Most of those, or in fact all of them really, sync via their respective clouds. If you're uncomfortable with this aspect of them, so you don't trust them, which is fair enough, then you may be able to disable device synchronization, and you can certainly do that on the Apple devices by turning off or disabling iCloud synchronization. There may be a risk of other things not working, but nonetheless you can do that. Or perhaps better still, adopt a hybrid solution where you use a cloud-based password manager for your day-to-day authentication and supplement that with a standalone FIDO key for the more important stuff, such as bank or medical records. Remember, FIDO keys don't synchronize with anything. The risk there, of course, is that you lose the FIDO key, and they're quite expensive. So that concludes today's presentation. Although I should point out there are some additional reference materials included in the slide deck, which I'll publish next week. So thank you for joining us. I trust you found this webinar useful and of interest. I'd just like to add a special thank you to Roberto and the whole NTF team and Jesse for facilitating this presentation today, and also to Promonic for the Domino server that we've been using today. So thank you very much. I don't know, do we have any time for questions?
We do indeed, and also thank you. And so I will share the screen for how you ask questions. We do have a fair few already, so
okay.
I'll go through those.
I'll do my best.
Starting from the bottom, does Passkey work in combination with HCL Traveler and the Verse app on mobile phones?
I knew someone was going to ask that. They're not my specialist subjects. I don't believe they do at present, but I could be wrong. I'll leave it at that, but I'll be happy to research that once we've finished and get back to whoever asked that question. Will I be able to get a list of the questions, Jesse?
Yes. Yeah.
Okay. I'll get back to you on that one, but I don't believe so today. That may change in subsequent releases.
All right, next one. Actually, I think there are two here that are related. Basically, can both Passkey and TOTP be configured for the same website?
Sorry, could you? So Passkey and
TOTP, the time-based,
the short answer is no. What you would need to do is set up a separate internet site for Passkey. So, for example, passkey.mywebsite and totp.mywebsite, and then you would log into whichever one you need. I think it's predominantly down to the form mapping within the DOM CFG. And if I recall correctly, Keith Brooks mentioned that a little while back in one of his books.
Sorry if I join all of a sudden, but I put a link in the chat because Rainer Brandl blogged about this, Passkeys and TOTP, and yes, the answer is no, as Paul said, but he gives details on how to set it up. So that it works with the two websites. And second, Dave Kern, our beloved resident paranoid, which you all know, says that Verse relies on Domino HTTP server, so Passkeys work fine with Verse.
Oh, brilliant. Thank you, Dave.
Traveler has a client side up and does not yet support WebAuthn. So, by the way, all the answers from Dave are in the general channel on our Discord servers if you want to read them later. I'm just reading it right now.
Thank you, Dave.
Back to you.
Doing all my work for me. Thank you.
The next question was, what was the Windows special password necessary to set the passkey? I assume that's asking what was up with that Windows UI and not asking what your password is.
Yeah, so that's actually the Windows pin code. So if you're using Windows 11, that would probably be it uses Windows Hello. So if you're using Windows 11, you may and have a touch sensor on your device, you may have been able to do that instead. I'm still running Windows 10. I don't have touch enabled, therefore I have to type my Windows pin code in. Hope that answers that question.
I think so.
Next one, just proving that I'm the person requesting the password, the passkey.
Next one came up a couple of times. What version of Domino does this require?
14.
All right. Next one also came up a couple of times. One with the assumption that it does not work. So what's the deal with this and directory assistance databases? Like, do the users have to be in names NSF?
That's a very good question. Because I don't know for certain, but I would guess that because the Passkeys database or the Passkey database manages the passkeys, if Domino is configured to use multiple names.ss effectively, or then that may work, because it's the Passkeys database that effectively manages all the keys, and that acts almost like a proxy between the web server and the Domino authentication. So I'm thinking it probably will work. Theoretically, I see no reason why it wouldn't work, but as is quite often the case, the proof is in the pudding.
Sorry, again, I'm monitoring Dave answers. First of all, Dave says you can configure Windows Hello on Windows 10.
Oh, okay.
Up to you, Paul, to find out how. But he says we tested Passkeys authentication with secondary directory assistance or another Domino domain, and it works fine.
Brilliant.
So
thank you, Dave. Again.
And I guess this
right.
also is the answer to Martin's question.
Yes.
Yeah. Next up, so what's the story with Passkeys working on a shared device? So multiple users logging into the same computer with different accounts. What's the contamination situation there?
So that's effectively down to the operating system. So if you're on a Mac, if you log on as a different user on the Mac, you'll get a different key chain, and the same process. The same should be, and it should be the same for a Windows device. Because it's part of your user account, it shouldn't be contaminated. It shouldn't contaminate to another user's account as long as you log in. Obviously, if you don't have that said, if you've got two users that share a machine and user A creates a passkey and user B tries to use that passkey, then user B won't be able to use it without authenticating or approving their presence, be it a fingerprint or a pin, unless they share the pins or fingerprints, of course. So it is I would say, quite secure in that aspect, unless you have a physical attribute such as the same fingerprint, or know the pin for the other device, then I think that's fairly safe. It's not something I've actually tried, but that seems quite fundamental to passkeys.
Yeah, that makes sense. And then the last one we have at the moment, isn't it a security problem that the original password is still saved on the Domino server and you could still log in with it?
Yes, I knew someone would ask that question. Yes, so it doesn't eradicate the passwords that are stored. So as I said earlier, the specification allows for unique identifiers, not necessarily accounts. Domino does store the passwords there, and if you think about it, really, you're always going, if you're using a secure system, so a system where you need to actually log in rather than simply create a unique identifier, as I demonstrated earlier, you're still going to need some way of creating that initial connection. So I suspect passwords will be around for quite a while longer, but the key thing is that you only need the password when you initially register for a passkey, or if you have to or if you have to get a passkey again. So at no time other than that first instance do you need to use your name and password. So your exposure to that password being stolen by a man-in-the-middle attack, or even phishing, is really quite low, because if you're phished, then it's simply not going to work, because your passkey isn't going to work for that site. Does that make sense?
Yeah, I think so. I mean, and yeah, because this is something when I was looking into it, I was like, yeah, but it's kind of like a migration from the current world of passwords only to passkeys first, and there's hurdles and things like that. But yes,
exactly. I'm not sure where that will go. I think passwords will be around for a lot longer. How you would replace them with something to prove your identity, I'm not quite sure. Really, thinking ahead, you would need some unique way of proving your identity, certainly in a corporate world. So not quite sure how that would get resolved. Probably an excellent question for HCL.
Yep. So if I can jump in
By
here
the way,
briefly, Dave Kern here.
I
Dave?
enabled Dave mic so he can, rather than type the question and I read the question to you, he can ask directly. So,
Sounds perfect to
welcome,
me.
Dave. It's a pleasure
Hello,
to have
Dave.
you.
Thank you. It's a pleasure to be here. So we're definitely looking at this issue. We have some requests around disabling password authentication for users who have registered a password. The question there is the recovery scenario.
Yes.
So, if you lose your FIDO key, if you get locked out of your Windows account, how do you recover from that type of a scenario without being able to fall back to a password?
Exactly.
And so the approach that what we've been doing inside our internal deployment is if you look at the passkey database, it's actually set up for you can see who recently logged in with their passkey and sorting by login time. And so you can track who has registered passkeys, who is using passkeys, who isn't. And you can then go and, nag the people who are still using passwords. Okay, I'm disabling password authentication on this date. You darn well better switch over now or you'll be left out. And so you can go into the internet site doc and disable password-based authentication once you have a steady state, and then provide an internet site that does have password-based authentication and just enable people for it briefly for those transitional states. You have new users coming in, you have users who need to recover, and so we don't have a technical solution for you yet because we don't know how to best present that recovery scenario, but you can certainly build one yourself using multiple internet sites today.
Yeah, I think it sounds quite reasonable, Dave. Thank you. Well, thank you very much for everyone for joining us, and particularly for Dave for answering all my questions for me. It's much appreciated. I hope you enjoyed the presentation, and I hope to do another one for OpenNTF in the future. Thank you very much.
Thank you very much as well. And as Roberto mentioned, everybody, Dave did chime in the general chat in OpenNTF Discord. So if you're not in there now, go to that URL and join. And so we will see you all next month.